So this is the first question of Lead Code Contest 374. In this question, you'll be given an array which basically represent like the heights of mountains, and you'll be asked to find all the peaks in the mountain array, right? So a peak element is basically a number where the adjacent elements are smaller than that element. So if you look at this test case, 14385, here 4 is a peak element because the element before 4, which is 1, is smaller. Element after 4, 3, which is also smaller. Now it cannot be equal. Peak has to be strictly greater than the adjacent elements, right? And the constraints of this question are the length of the mountain array is up till from 3 up till 100, and every element in the array is also in the range from 1 to 100. Okay, so yeah, let's see how we can solve this question.
So in this question, we have given the array mountain, and we have to find the peak elements. Peak elements means that we can understand it by graph. For example, we have the graph here. So 1, 2, 3. Let's take the example of first one. This 1, 2. Now we have the element 2. So we will point it to, and we have the element 4 here, and we have the element 4 here. So the graph is like that, but it's not making, yeah, it's the greatest element, but it's not making a peak. Peak means that if we have a graph, then this is the peak. So which means that if we have the area of I minus 1 here, we have the area of I, and we have the area of I plus 1 here. So the condition is that array of I should be greater than array of I minus 1, and array of I should also be greater than array of I plus 1. So for this question, we have to check for each element, and as they said that first and the last element can't be peak, as it can also be understood as because first element doesn't have any element in its left, and last element doesn't have any element at its right. So we are taking the second test case, which is this. So let's suppose we are taking array 1, 4, 3, 8, and 5. So we will start from 1 as first 0, 1, 2, 3, 4. So here array of 1, if we check for array of 1, so it's 4, and array of 0, 1, and array of 3, 2 is 3. So 4 is greater than 1, and 4 is also greater than 3. So it's satisfying the condition. So it will be considered as the peak, as because we if we make the graph here, so 1, 1, 2, 3, 4. So 1 is here, 4 is here, and 3 is here. So yeah, it's creating a mountain-like structure, and we can consider 4 as mountain. So it's the solution. As we have given, as in question, we have given the array, and we also have to return the array. So we will create an array like vector. We can create a vector of integer indexes. Yeah, in this question, it is also can be observed that we only have to pass the indexes, or we only have to give the indexes of the element, not the particular element. So if we iterate through array, so we will get 1, 3 as the indexes. 4 is satisfying the condition, and 8 is also satisfying the condition. And apart from that, nothing. Another elements are not satisfying. So the answer will be 1 and 3. If we talk about the time complexity, So it is given that the size of the mountain array will be 1 less than equal to n less than equal to 100. So as we are traversing the array, so time complexity will be big O of n. And we have to return the array of indexes. So we can consider space as vector, which we are returning, where we can have the mountain peaks as if we have the 100 size as maximum, so we can have only 50 as maximum peaks. So in this case, the it will be big O of 50, or we can consider it as big O of n also. Yeah, so it will be the answer of that.